We're going to pick up where we left off last time in 6.3, multiplication division of rational numbers. And what we were working on when we stopped is we were working on properties of exponents. And just to remind you of them, we'll go through them really, really fast. These are the first 6. If we have the multiplication same base, we can add the exponents. Different base divided, same base divided, we can subtract the exponents. If we have an exponent to an exponent, we multiply. And then we've got the 2 that are sort of like distributive properties, 4 and 5. And then number 6 talks about what happens when we have a negative, and it just does reciprocals. And then the other 2 we did at the very end were 7 and 8. We talked about why a to the 0 is equal to 1. Showed you how to deal with that one. And then the last one was that a to the negative n is going to be 1 over a to the n, and it's sort of just a specialized case of the number 6 that we had before. All right, so all of that was well and good, but I did mention last time the point is not for you to actually repeat this particular argument on every single problem. There's a reason we have the argument so that we can make the problem simpler. So as we're taking a look, that's our goal. Our goal is to actually use the properties to solve the problem in a simpler way. And there's often more than one way to use the properties. So the order in which you do it may not match the order in which I do it or someone else does it, and we could both end up with the same answer and both be correct from our methods. All right, so the first one, if you take a look, we have ab to the 4th over a to the negative 3rd b squared. And there's several ways to start with this one. So what do you guys want to do? Okay, we could do that. The a to the negative 3 could just move up to the top. We could do that. So this would be ab to the 4th, and then a to the 3rd over b squared.
So the a and the b have to stay together. You can't make it like...
Nope, you can separate them.
Oh,
that was just her first suggestion.
Oh, but you can't do like a to the 4th, like on the top.
Yeah, we're going to. We just aren't there yet.
Oh.
I was just doing the one that she told me to do. So yes, you can jump right to there if you'd like. I'll show you a couple ways to think through this one. What would we do next? That's what you would like to do next, right? Well, it was a to the negative 3rd in the denominator. But now that it's in the numerator, it changed signs. Okay? You want to move the b to the top? Okay, we could do that. ab to the 4th, a to the 3rd, b to the negative 2. All right, if I move it up, it changes signs. Some of you are like, I wouldn't have done it that way. That's cool. Now what? All right, so we can add and subtract things. So how many a's do I have? There are 4 of them. How many b's do I have? I have 2 of them. And then I'd be done. Did that method work okay? It did. A couple things, like could we have sort of skipped over the second step and jumped straight from the first one to the third one? Sure. Could have moved both of them up at the same time. Anybody try or think to do something differently from the very get-go than what I did? You canceled some things out. So what did you cancel, Haley?
The 2 and 4, or the 4 became 2.
So with your b's, you looked at the b's and said b to the 4th, and I've got b squared. So I'm going to reduce both of them by 2 b's, basically like b squared, a b and a b, like multiplication of b's. Sure, you could do that. So this became b squared, and this one just went away because it was divided out. That's a possibility first. Anything else? You could. It's a little trickier with the a's, though, right? Because one of them is positive and one of them is negative, so it's got this sort of a weird feel to it to do that. But you could sort of think about it in that way. When I look at this problem, I just want to go straight to the property number 2, where I subtract a to the 1 minus negative 3 and b to the 4 minus 2. That's what I do. I just subtract exponents. That works too, right? Again, it's a little awkward because I've got a 1 minus a negative, so you do have to be careful and remember that's not really going to be a subtraction problem. Once I simplify, it's going to add, right? But it works too. I bring this up not to confuse you. I hope I really didn't. But just so that you are aware that just because you're thinking through it a little bit differently, be really careful not to tell somebody else that they're doing it wrong. Because they may legitimately doing something, I mean, they may be doing it wrong. I mean, that's possible. But they may also just be thinking of it in a different order or in a different way, okay?
Wait, so you subtract what you're doing, it's not dividing the exponents?
Division subtracts exponents. That's property number 2. Yeah. All right, what's different about B than A? There's a couple of things. All numbers instead of variables. That's issue number 1. What else? We got a negative exponent on something. That's true. That wasn't one I was thinking of, but you're exactly right. That's something different. What else? What was that? The whole fraction has a power to it. You guys are doing so good at observing things that I wasn't even trying to think about. But you're right. These are all different things. What was that? That's true. We're multiplying and not dividing. Anything else?
If you reduce 4 over 25, it would be 2 over 5.
All right. So you've said it not quite the right way, but you've hit on the issue. The issue right now is that what's inside the parentheses doesn't match. Do you guys see that? They're not the same. One of them says 2/5, and the other one says 4 over 25. So I'm not going to be able to use any of those properties right now from this point right here because they don't match. All of those properties were working because what was being operated on, raised to a power, whatever, they were the same. And these are not the same. So I can't just combine them and say, oh, look, I'm just going to add 3 and -6. No, I can't do that because the bases are not the same. Now, in order to be able to use the properties, I need the bases to be the same. So we're going to do what you're suggesting is somehow change the 4 over the 25 to make it look like 2 over 5. Okay? But I can't reduce it exactly because 4 and 25 don't have anything in common. We can write it as a squared instead. So what we're going to do, and again, there's other ways to think about it. This is just one of the ways, is I'm going to leave this 2/5 alone, just like he is. But I'm going to change the 4 over the 25 to say 2 over 5. And I'm going to write a squared on that. And then all of that is to the -6. So what you see is that this piece right here is replaced with this piece right here. Okay? -6 is on the outside, just the same as before. The 4 is now the 2 here. The 25 is the 5. But in order for it to actually be the same value as before, that 2 over 5 is squared. Is everybody okay with that? The other thing you could do is you could somehow manipulate the 2 over the 5 to become a 4 over 25. It's a little bit more awkward, actually, to do that, but that is another option.
If you did it that way, would you multiply like the other way too?
What you would do is you would take that 3 and you'd have to change it in some way so that you had like the 2 over 5 times 2 over 5 times 2 over 5, and you'd have to manipulate with the 3 2 over 5s. And the reason that's awkward is because there's 3 of them instead of 4. If we had 4 of them, it would actually be pretty clean. But with 3 of them, it's very awkward. So, yeah. The other thing that's nice about doing this one is that it's in a reduced sort of form. I can't do anything with 2/5 to simplify it any further. There's no other way to clean it up or make it smaller. And smaller fractions are typically more easy to work with. That is really not good English, which is why I paused. Yep, they're easier to work with. So, all right, this aside, take a look now at the fact that I've got a fraction, not the fraction itself, but I've got a power and a power here. What can I do with those two powers? Combine them. How? With multiplication. That's actually property number 3. It says that if I have a power raised to a power, I can multiply the exponents together. So this is actually -12. Now I have the same base, 2 to the 5th, with an exponent of 3 and then an exponent of -12. What can I do next? Combine them. How? With addition, right. So I need to add 3 plus -12. What will that give me? That's -9. Now, in some sense, that's a really good form for it to be done. But there is something that's wrong with it based on the directions of this particular problem. What's wrong? Yeah. These directions were very clear up here, and they said that we're supposed to have positive exponents. So that's not okay, because right now this has negative. Okay, so Emma is suggesting that I do something where I turn it into something like this. And legitimately that works, but it's a little bit awkward. Do you know why? Yeah, it's a fraction inside of a fraction. Another suggestion then, so that we can avoid the fraction inside of the fraction.
You can just flip the numbers.
We could flip the numbers. That's actually property 6. So property 6 says what I could do is I could change this. Instead of it saying 2 over 5, it could say 5 over 2. And then the exponent, instead of being negative, would now be positive.
And that was 9, you said?
What was 9? 6. Yeah, that's property 6. Property 6 says I have the ability to do the reciprocal to sort of eliminate the negative. Yeah. Any questions on that one? There's a lot of weird things in that one. So, yes.
So do you always have the parentheses around it just so that it's clear where the exponent is?
Yeah, when there's a fraction, the parentheses will help us to identify that that exponent applies to the numerator and to the denominator. Yeah. Mm-hmm. Any other questions on that one? Awesome. All right, let's take a look. I think there's one more, isn't there? Oh, there's a couple more. These are equations or inequality. One of each. There's an equation and an inequality. All right, so it says that we're going to solve for n if possible. I think that the directions say that exactly in your book. I'm pretty sure in all cases it's possible. So I'm trying to save you the trouble of saying, like doubting yourself as you're working the entire time. Is this possible? Is it even possible? Am I trying to find something that doesn't even work? I'm pretty sure they all work, if I remember right. So let's take a look at these. What we're going to do is we're going to actually use the properties of exponents to make this easier on ourselves. So on the left-hand side, you'll notice that you have two bases that match, and there are exponents associated with them. So is there a way to simplify what's on the left?
Make that into the exponent of 2.
Okay, so base 2. What would my exponent be? Right, n plus 7. I mean, I can't actually get a simpler way of writing that, but I can write it as addition, right? Okay. Now, what my goal is to turn the right-hand side also into 2 to some power so that I can compare them. If I have 2 to a power on the left and I have 2 to a power on the right, then I can talk about the powers as though the 2's kind of don't matter because they already match. So grab your calculator out, and I want you to just play with it for a second. Start with a 2. Your button may look like a kind of a caret button, like on a computer screen. So you can put in like 2 to the 3rd, right, like this. Or it may look like sometimes it looks like a y to the x button that you have to push to get an exponent. Depends on your calculator. But I want you to play with 2 to a power and see if you can figure out what that power should be to make the number 64. What did we get? To the 6th, I agree. Okay, so for those of you who didn't play with it long enough to get to that, just double check. Put in 2 to the 6th and see if it works. Do you get 64? Yeah. Okay, so here's the cool thing. If it's true that this is 2 to the n plus 7, and this is 2 to the 6th, the only way they're going to work is if the exponents also match, right? So I'm not canceling out the 2's. That is absolutely not what I'm doing. But I am ignoring them, okay? I'm going to completely ignore those exponents. Not the exponents, the bases, because they match. They become rather irrelevant at this point, okay? So my exponents must now match, which means that it must be true that the n plus 7 is equal to 6. Either simply by looking at that and thinking through what does n have to be, or by solving it and subtracting the 7 to the other side, you should be able to find out that the n value is actually what? It is -1. Does that make sense? All the problems you're working with have the ability to be changed so that the bases match. Sometimes have to be a little creative to make them happen, but they are able to be done in that way. Okay? Is that true in general with every single problem that has exponents? Well, of course not. But the problems that you're encountering with this whole process right now all have this feature. Okay? So the second one down here is the same sort of thing, except for it looks a little awkward for a couple of reasons, which you're probably going to find 4 of them because I have only seen 2 right now, and you guys are going to come with something else, which is very cool. So somebody tell me something you see that makes this look a little different.
It's a fraction and an exponent together.
Good. So one side actually has a fraction going on. That's a little awkward. What else? Inequality. You guys have the 2 that I saw. That's fabulous. It is. It's an inequality. Now, let me just tell you, the fact that it's an inequality changes nothing. Less than, greater than, equal to, doesn't make any difference. It just means that that sign is going to be in the answer, okay? So we're not going to do anything different with the sign. I mean, nothing. But the fraction is going to have to be dealt with differently. All right, so as I'm looking at this fraction, the 1 over the 81, just ignore the 1 for the moment. I promise we'll come back to him, but let's just think about the 81, okay? And it might help as you're thinking about these sometimes, especially if it's a larger number like 81, to try and figure out what in the world the factors are of 81. What are they? 3, and then what would be the other one then? 27. If you get 27, then what are you going to have? 3 and 9. And if you get the 9, what are you going to have? 3 and 3. And we could have done the same thing with 64, by the way. I mean, I let you play around with just trial and error, which is totally fine. You could also do this one with trial and error to try to make it 3 to some power. But you can factor it, too. What is this factored into? This is 3 to the 4th. So on the left side, I have 3 to the n. On the right side, I still have a 1 on top, but I have a 3 to the 4th on bottom. Okay? I don't want 3 to the 4th on bottom. I want it on top. So I can make it 3 to the negative 4th. Very good. Do they match now? Yes, they do. I have 3 as my base on both sides. So now I can ignore the base and look only at the exponents. N on the left, negative 4 on the right. What's going to go in between? Less than or equal to. Same symbol I had before. No different. Okay? Any questions on that one? Yes?
I'm just kind of like looking back at the letter A, and I'm just like, my first thought was like multiply 2 and 2, and then like cut in multiple, you have to add the 7 and the n. And I'm just like, that's like, I don't know, I'm going to get stumped, like I know that I will do that to myself and then forget.
Like you want to turn the 2 and the 2 into a 4? Is that what you mean?
Yeah, like I know looking at like, especially from like, looking at algebra and stuff, like how do you solve for x? That's what I would have done initially, and I'm just like, well, how am I, like,
Yeah, the problem is that you have to recognize that you can't multiply them because they have exponents. Do you remember order of operations, either please excuse my dear Aunt Sally or PEMDAS or something like that? Well, exponents come before multiplication, right?
Yeah.
Which means you have to either simplify the exponent all the way out, which you could do with the 2 to the 7th. I mean, that'd be okay. Or you have to in some way combine them without actually doing the multiplication. So that's what's going on there, is that you're reversing your order of operations. There is one other thing you could do. I'm not necessarily saying that this is any better, but you could actually figure out what the 2 to the 7th is, and you could divide both sides by it. Now, if you do that, it's going to be a little bit more complicated because you're going to end up with a fraction on the other side. And then it's going to turn into a problem kind of like part B, because now you're going to be dealing with a fraction. Totally doable. It's just going to feel a little bit awkward in the middle of it. So you could do that too. Yeah. All right. Approximation problem. 20 and 1/3 divided by 9 and 7/8. So the question you asked earlier, Lauren, from the last section, where you were like, I know that doesn't sound right because it just, like, that can't be the right answer. I mean, this is one of those things where you're just saying, what would it approximately be if I was trying to sort of look at this information so that if I actually did the problem all the way out, I'd know if I'm in the right ballpark. Well, that's just all the problem's asking you to do, is to approximate. What would be easier to work with than 20 and 1/3 and 9 and 7/8? 20 and, how about 10? Yeah, I like 10. Because 20 divided by 10 would be 2. So if we were actually doing this problem, longhand worked out, our answer better be somewhere in the ballpark of 2, or we've made some kind of an error. Okay? So you've got a couple problems with approximations in here. All right. A couple of examples of exponential and multiplication kind of things with fractions with some context. All right, so we've got Jasmine, and she's reading a book. She has 1/4 of the book left. Okay, so like this would be like what you'd look at the side of the book and you'd be like, oh, I've got about 1/4 left. Okay, this is what she's doing. 1/4 of the book left, but she also knows that she's on, or she has read 246 pages. Okay, so does anybody read on electronic devices like Kindles or maybe your phone or something like that? They do this sort of thing too. where sometimes they'll still have the page number on the screen because they did it from an actual PDF sort of version of something. So you can see that it says you're on page 246, but it also tells you in the bottom 75% read or 25% or 66% or something like that. So this kind of has that feel to it. I mean, like, because obviously she should be able to look at the last page of the book and say, oh, there's this many pages in the book. So we're presuming that is not possible the way that she's got this set up, okay? Or at least in that frame of reference. All right, so the thing is, she says she has 1/4 of the book left. She's read 246 pages. How many pages does she have left? So what in the world might you do to solve this problem? And there's more than one way to do it.
You'd set 246 over x, and then equal it to 3/4, and then cross multiply.
Okay, remember your name? Emily. Okay, so Emily's done this in a proportion form, which I absolutely love, and we're going to talk more about proportions in section 6.4, which is our next section. So she set it up like a proportion. So what's going on here then, the way she set it up, is this is what we've read already, right? And this is the total in the book. That's not very readable, but total in the book. So then the 3/4 would then be representing that she's read 3 out of every 4 pages of the book, or some variety like that, okay? All right, so then what did you want to do next, Emily?
Like cross multiply.
Fabulous. We can cross multiply. So for the sake of time, what is 246 times 4 in your calculator? 980?
94.
984, okay. And then the other one is 3x. So what does x end up being? 328. Okay, now this is one of those cases where x is equal to 328. We need to make sure that we've answered the question that was asked. And have we?
No.
Not yet. What is x in our problem? How did we set it up? It was the total number of pages in the book. But they wanted us to find how many pages she has left.
So to subtract the 246.
You could. That's one way anyway. Yeah, so we could take the 328 minus the 246 that she's read. And what would that give us? 82. Did anyone else think of a different way to do that besides, I mean, not that subtraction's difficult or anything like that. That's not my point. But did you think of it differently?
You could do another proportion and do 1/4 equal to x over 328.
You could. You could set up a second proportion. And the equivalent of doing that is also just recognizing that if she's got 1/4 of the book, you could just divide the number by 4. That's another thought. So a couple of different ways to finish that out. So there's 82 pages that she has left. In any which way we do it, it is 82 pages. Yeah. Excellent.
Couldn't we just divide the 246 by 3 to get?
You could. Yeah, if you recognized at the beginning that if she has 246, like for instance, none of this is actually what I have written down on paper, by the way, just so you know. I did the problem completely different than this. I love proportions, and I usually do proportions. I think I didn't because it's not actually in there until 6.4. But one of the things that I did was more akin to what you're describing, Amy, is that when I did the problem, I did this. I set up an equation like this, and then you can see where that 3 is right there. So in some sense, you're going to end up dividing by 3 because what you would be doing is multiplying by 4 over 3. It's not exactly what you're describing, but it has that same similar feel to it that you will end up dividing by 3 somewhere along the way. Yeah, you could. Anyway, yeah.
If it's 3/4 and you want 1/3.
1/4. Yeah, because you have 3 times as much as what she has left. Yeah, definitely. All right, so, and any of those are perfectly fine. There's not a specific way you're asked to do it. So, all right, one more in this section. Al. Al gives 1/2 of his marbles to Jose. Jose gives 1/2 of his marbles to Isabel. Isabel gives 1/2 of her marbles to Letitia. And Letitia was given 4 marbles. How many marbles does Al have now? There's a lot of people giving a lot of stuff away, right? Absolutely. Can I write them all down in order? I think that would help me. Does that sound good to you guys? Okay. So we started with Al. Our second person is Jose. After Jose, we have Isabel. And after Isabel, we have Letitia. right, so we do know something about Letitia, specific, concrete, hardcore. What do we know? She's got 4 marbles. And she got them all. She was given them all from Isabel, right? She got all those 4 from Isabel, which means that Isabel had 8. So she had 8 originally, correct? But what do we know about those 8 that she had? She got them from Jose. So Jose originally had 16. And what do we know about Jose's marbles? No, he didn't get half of them. He got all of them from Al. Al gave half of them, right? So how many did Al originally have? 32. But what were we asked to find? How many does Al have now? So Al has 16. You can divide by 2, or you could look at what he actually gives away to Jose and think about it that way. He has 16 marbles. And for those of you who took elementary math 1, you might recognize this as a working backwards kind of a problem-solving strategy. It works really well on this one. All right.